Hi guys, so Lynn here from the Dublin Academy of Education again. So for this fifth year chemistry lesson, we are going to continue on looking at oxidation and reduction. So this is part 4 and our focus for this part is going to be some exam questions. So we want to now have a look at how you can be asked about this topic on the Leaving Cert paper. So we're going to start off by having a look at a question from 2014. So it's part of question 10 from that year. It's worth 25 marks. Okay, and for my day school fifth year chemistry students, it's on page 55 of your notes. What I would actually encourage you to do is pause this video and have a go at this question yourself. So it's worth 25 marks. So give yourself about 10 minutes to have a go at it. So you'll see in it, there's a bit of theory related to our definitions of oxidation and reduction, and then you have a balancing of a redox equation. I'd like you to have a go of it yourselves first, so pause the video, give yourselves 10 minutes, and then I'll go through it, okay? So if we have a look at this question, we're first of all, for 6 marks, asked to define oxidation in terms of electron transfer and change in oxidation number. So this is the first 6 marks of our 25. So define oxidation in terms of electron transfer. Well, oxidation in terms of electron transfer is the loss of electrons. Okay, remember your oil rig, so the loss of electrons. And then in part 2, in terms of change in oxidation number, so oxidation is the loss of electrons, therefore the oxidation number becomes more positive because as electrons are lost, you know, where the charge is going up. So it's an increase in oxidation number. Okay? Okay, so this is an increase in oxidation number. So 6 marks out of our 25. The next part, use oxidation numbers to identify the oxidizing agent and the reducing agent in the following reaction. And I've written it up on the board here. So what we need to do is we need to assign our oxidation numbers. Okay, so we have Cd, cadmium on its own here, free element, therefore it's going to be 0. Okay, simple ion here, +1. -2 times 3 is -6. So what would we have to add to -6 to give us -1, which is the charge on that complex ion? Of course, +5. So +5 -6 gives us -1. Okay? Now on the right hand side, simple ion, so it's going to match the charge, +2. Here we have NO, okay, so -2 for the oxygen, then that's going to be a +2 for the nitrogen. Remember, they have to add up to 0 in a neutral molecule. And then our water at the end, -2, and then +1 for each of those hydrogens. Okay, so we've assigned our oxidation numbers. We now need to identify our oxidizing agent and our reducing agent using those numbers. So we have to look and see what has changed, okay? So we want to identify what has changed during this reaction, what has increased in oxidation number and what has decreased in oxidation number. So we see straight away that our cadmium has gone from 0 to +2, okay? 0 to +2, therefore this has been oxidized, okay? We have lost 2 electrons, okay? Lost 2 electrons. What else has changed? We see here that the nitrogen, so in this is our nitrate ion, then over here we've nitrogen monoxide, so we can see that it has gone from +5 to +2. So the oxidation number has decreased, okay? So therefore this has been reduced. Reduction involves the gain, remember oil rig, so reduction involves the gain of electrons, so we can see that we have gained 3 electrons. To go from +5 to +2, we have gained 3 electrons, 3 negative electrons, okay? Now, the question doesn't actually ask us to identify what's been oxidized and reduced. It's asking us to identify the oxidizing agent and the reducing agent. So, the oxidizing agent is the thing that is reduced during the reaction. Okay, the reagent that's reduced during the reaction. It's allowing something else to be oxidized. So, the oxidizing agent is this guy here. Okay, so our oxidizing agent is NO3 minus. Okay, NO3 minus. And then our reducing agent is the species that is oxidized during our reaction. Which in this case is our cadmium. Okay? Now, a common mistake that students make with questions like this would be to say, oh, the nitrogen is the oxidizing agent, the nitrogen on its own. The oxidizing agent is basically the chemical, the reagent that is added to act as the oxidizing agent. So you have to take the whole thing from the balanced equation. Don't just say nitrogen, you would lose marks for that, okay? So we can see that we've got 12 marks for what I've just gone through on the board. So we got 6 marks for our definitions, and now we've got a further 12 for assigning our oxidation numbers correctly and for identifying the oxidizing agent and the reducing agent correctly. Okay, so 12 marks. So we have a further 7 marks to get here. And we're going to be awarded these marks for balancing this equation, okay? We've done a lot of the hard work already. So if we think back to the previous examples that we went through of balancing our redox equations, this was a very important part of that process. So we've done a lot of the work already, okay? So what we're going to do now to balance this is separate out, take out these half equations for oxidation and for the reduction, okay? So we'll start off. So CD minus 2 electrons gives us CD2 plus, okay? And then NO3 minus plus 3 electrons gives us NO, okay? Now, we need to cancel these electrons. So what are we going to multiply each of these lines by in order to get these electrons to cancel out? We want the same number of electrons being lost as gained. So we're going to multiply the top line by 3 and the bottom line by 2, okay? So the top line by 3 and the bottom line by 2. So 3 minus 6 electrons and then a 3 over here, okay? Then the bottom line 2, 6 electrons and then a 2 in front of this, okay? So our electrons now cancel. We've the same number being lost and gained, so we're happy. We've balanced the electrons. We are now going to rewrite the first equation with those coefficients included, okay? So if I move over here, I'm going to rewrite this. So 3CD plus H plus 2NO3 minus, okay, gives us 3CD2 plus 2NO plus H2O. Okay, so the electrons have been balanced, but we still have to balance the atoms. So just as we've done in previous examples, left-hand side, right-hand side. Okay, so I always position this table just below the arrow to keep us on track. So cadmium, hydrogen, nitrogen, oxygen. 3 on the left, 1 hydrogen, 2 nitrogens, and then 6 oxygens. 2 times 3 for 6 oxygens. On the right hand side then, 3, we have 2 hydrogens, we have 2 nitrogens, and we see that we have 2 plus 1, so 3 oxygens. Okay, so 3 oxygens here. Now, let's start off. What we first of all see, our hydrogens aren't balanced, either are our oxygens. So let's start off with the oxygen. We need 3 more on the right hand side. Okay, so we've only got 3 here at the moment. So 2 oxygens here plus the 1 from the water. So we need 3 more, okay, to give us 6 in total. Again, it would be tempting to just put a 3 in front of this, because you think, oh, well, we need 3 more, so I'll put a 3 in front of this. If I did that, I would have 2 oxygens here and 3 here, which is only 5. So what we actually need, because we need 3 more, we put a 4 here, okay? So that will give us 2 oxygens from this, plus 4 oxygens now from the 4 water molecules. So that gives us 6 oxygens on the right hand side. But of course we can see that we've now also changed the hydrogens. So we have 8 hydrogens now instead of 2. Okay, so what we have to do to balance that, everything else is, we're happy with everything else being balanced in terms of the number of atoms. We go back over to the left-hand side and we put an 8 here, which then gives us 8 hydrogens on the left, and we have balanced our equation and we've been awarded our 7 marks, 25 in total for that full question. Okay? So we're going to move on now to have a look at our next example. Okay, so this question is from 2007 and it's on page 58 of the notes for my 5th year day school students. So page 58 of your notes. So we're going to have a look at this one next. Now, I'll just clear a little bit of space here. So again, what I would encourage you to do, even for those of you that don't have the notes, if you look this exam question up online, you'll be able to access it. So as I said, it's from 2007 and it's question 10C. Okay, so 2007, question 10C, again worth 25 marks. So what I would encourage you to do is look up the question, okay, and give yourself 10 minutes. 10 minutes, so pause this video again and give yourself 10 minutes to try it yourselves, okay? And then of course I will go through it with you, but it's really important that you are getting some practice of these yourself. So pause the video, okay? 10 minutes, off you go. Okay, so 2007, question 10C, let's have a look at what we're asked to do here. The halogens are good oxidizing agents, okay? So, how does the oxidation number of the oxidizing agent change during a redox reaction? Okay, so an oxidizing agent. Remember, the opposite to what you might expect happens to an oxidizing agent. An oxidizing agent allows something else to be oxidized during the reaction. So that means that it's gaining electrons. Okay? So, if something gains electrons, it's reduced. So what does that mean in terms of our oxidation number? Well, it means, of course, that our oxidation number is going to go down. Decreasing oxidation number. Okay? Now, we're told in the question that the halogens are very good oxidizing agents. And we can explain that because of their position on the periodic table. The halogens are in group 7. Meaning that they have 7 in their outer energy level, they want 1 more, they're very good at gaining electrons, okay, so they're trying to gain electrons. So therefore, the halogens are good oxidizing agents because they're very good at gaining electrons. So their position on the periodic table helps us explain that. But for the first 4 marks there, that's the piece of information that we need. Our oxidation number goes down, it decreases. All right, now, assign oxidation numbers in each of the following equations to show clearly that the halogen is the oxidizing agent in each case. So let me just very quickly write these up here. So the first equation, we have bromine plus iron 2 to give us bromide plus iron 3. Whoops, sorry. Okay, to give us iron 3. Okay, and then our second equation, we have chlorine plus the sulfite ion plus water gives us chloride plus the sulfate ion. Okay, so we now have to assign oxidation numbers across these 2 equations. So the bromine, Br2, is going to be 0, okay? This is a simple ion, so it's going to match the charge, plus 2. Minus 1 to match the charge here, and then plus 3 to match the charge in this case. Now, what we're being asked to do here is to show clearly that the halogen is the oxidizing agent. An oxidizing agent gains electrons, therefore the oxidation number will go down. And that's exactly what we see happen here. Okay, 0 to minus 1. Okay, therefore this has been reduced. Okay, it's behaving as the oxidizing agent. So we've identified bromine, which is one of our halogens, as the oxidizing agent in this reaction. If we look at the second one, we have 0 for the chlorine, minus 2 times 3 is minus 6. Now what would we have to add to minus 6 to give us minus 2? Plus 4. So let me just say that again. Minus 2 times 3 is minus 6. The sum, so all added together, we have to get minus 2. So minus 2 times 3 is minus 6. We add plus 4 to give us minus 2. Minus 2 plus 1, minus 1, because it'll match the charge on the simple ion, meaning we've just one charged atom. Minus 2 here, but this time it's times 4, so that's minus 8. What would we add to minus 8 to give us minus 2? Plus 6. Okay, plus 6 minus 8 equals minus 2. And then plus 1 for the iodine at the end, for the hydrogen, sorry, at the end. Again, we are trying to prove that our halogen, the chlorine, is the oxidizing agent. And we see that it is, because it's going from 0 to minus 1. Therefore, it is reduced during this reaction. Okay, therefore, it's acting as the oxidizing agent. So we have proved that that the halogens are behaving as the oxidizing agents. Bromine in the first example and chlorine in the second. So oxidizing agents have decreasing oxidation numbers because they're gaining electrons. So their oxidation number will become more negative. All right. So we have been awarded 12 marks for that. So 4 plus 12, we've 16 out of our 25 marks. For the next 6 marks, we're asked to balance the second equation. So we're just focusing in on the second equation. So we've done a bit of the hard work here. We've assigned all of our oxidation numbers. We've identified that the chlorine has been reduced, okay, from 0 to minus 1. So if we think about that in terms of how many electrons have been gained, we can see that we have 1 electron gained in that case. And then if we look at what else has changed, we see that our sulfur in the sulfite to sulfate, remember SO3 2- is sulfite. That was one of our complex ions that we came across when we were looking at chemical bonding. And then this is the sulfate ion. So we're going from plus 4 to plus 6. Okay, so that means that this has been oxidized. Okay, remember the oxidation number is going up, so it's been oxidized, so 2 electrons have been lost. Okay, so I'm going to rewrite the 2 equations, the half equations, the reduction and the oxidation, just like we've done in all of the other examples we've looked at. Now, I'll rewrite them over here. So we have Cl2 plus an electron gives us Cl minus, okay? And then the second one we have SO3 2- minus 2 electrons gives us SO4 2-. Okay, so we want these electrons to balance. So we're going to multiply the top line by 2. Okay, we multiply the top line by 2. So we put a 2 here and a 2 here. I don't put a 2 in front of that Cl2. If we think back to the example we did in the previous video, that was a similar situation. If I put a 2 in front of this, that would mean I had 4 chlorine atoms here, whereas we only have 2 chloride ions here. So they would not balance. So because we have 2 chlorides here, I just leave that as Cl2. I do not put a 2 in front of that. And again, that's an important thing to make sure you've noted down correctly. Now, our electrons cancel out. Okay, we have 2 electrons being gained, 2 electrons being lost. So we're going to rewrite the original equation with these new coefficients, but as we can see, not that much has changed. Okay, it's a simple enough example, which is very nice. So we have Cl2 plus SO3 2- plus H2O, which gives us 2Cl minus plus SO4 2- plus H plus. Okay. Final step then, we need to look at the number of atoms that we have. So chlorine, sulfur, oxygen and hydrogen on the left hand side of our equation and on the right hand side of our equation. So on the left hand side, excuse me, we have 2 chlorines, we have 1 sulfur, we have 3 plus 1, which is 4 oxygens, and we have 2 hydrogens. Okay, on the right hand side we have excuse me, I'm losing my voice here now. We have 2 chlorines, okay, 2 chloride ions, we have 1 sulfur, we have 4 oxygens, and we have 1 hydrogen. Okay, so it's not too much to be done here actually, as it turns out. We are pretty much happy with everything except the hydrogens. We need an extra 1 on the right hand side, which we can get just by simply putting a 2 in front of that H+, and now we see that we have balanced our equation. So we got 6 marks plus the 12 for identifying our oxidizing agents and assigning our oxidation number. So 18 marks. So you do get very well rewarded in questions for being able to assign those oxidation numbers. Okay, it's a really important thing to make sure you're confident with. Now, the final part of this question, we still have 3 marks remaining. So we've got 22 of our 25, 3 marks left. So why does the oxidizing ability of the halogens decrease going down the group? Now, this question actually relates to one of the mandatory experiments, the mandatory experiment from this topic, which we will look at in our next lesson. But what we see here is that why does the oxidizing ability of the halogens decrease going down the group? So let's just recap for a second what we mean by oxidizing agent. An oxidizing agent is something that is good at gaining electrons. Okay? Now, as we move down the halogens, they get worse and worse at doing that. Okay? So as we go down the group, so we start off with fluorine at the top, then chlorine, then we have bromine, and then iodide. So as we go down, their ability to gain electrons is decreasing. That's really what this question is asking us. Why is that the case? Why, as we move down the group, are they less able to attract electrons? Okay? The reason for it, if we think back to our trends of the periodic table and what all we discussed when we had a look at that topic back earlier on in the year, as we move down the group, these elements are getting less able to attract electrons. Their electronegativity is decreasing. And the reason for that is that we have an increasing atomic radius, okay, which is obviously something we've discussed before, but let me just recap it very briefly. That means that the atoms are getting bigger, which means that the outer electrons are further from the nucleus. So an atom's ability to attract electrons is totally reliant on the nuclear charge, the positive charge of the nucleus. So the stronger that positive charge is and the closer it is to the outer electrons, the more able they are to attract them in. So big atoms down at the bottom of the halogens are less able to do that just because the nucleus is physically further away, and we have lots of extra shielding as we move down as well. Okay, so we have this increasing atomic radius, and of course, as we mentioned, we have an increasing, sorry, not increasing, we have a decreasing electronegativity as we move down as well. Okay, so we have a decreasing electronegativity, and don't forget electronegativity, this is a nice bit of revision from another topic. Electronegativity is the ability of an atom of an element to attract electrons. It's the relative attraction that an atom of an element has for a shared pair of electrons in a covalent bond. Okay, so we've gone through those 2 full questions now, 25 mark questions, sorry, they're half questions, 25 marks, very typical of the kind of thing we would see in relation to oxidation and reduction on the exam, and as I said, I think it was very important that you did try them yourselves, but hopefully now if you have followed with me here, you'll be able to correct the work that you did, and well done on that. Thank you.